and good morning. Today we are going to touch back on functions. And as you see, it looks like I misspelled it here with an extra C, but the inverse of functions we're going to talk about. Now, before we do that, let's touch back again on what it means to be a function and also how we determine if it is one-to-one. Okay, so as we talked about back in section 1, if we are trying to determine whether a function or something is a function, remember we know that each of our domain goes to one range. Okay, so each of our x values can just go to one y. So if we look here, we have 3 different sets of points here, and they're represented below here in this graph. Now the answers are already here, but if we look at this first one, this is not going to be a function. 0 goes to 0, but 1 goes to both 2 and 1 goes to 3. That disqualifies it from being a function. Now the second one here, g, this will be a function. 0 goes to 0 again, 2 goes to 1, 3 goes to 1. However, it would not be one-to-one, okay? Because if we think about it the other way, 0 goes to 0, but 1 goes to 2, and 1 goes to 3. Okay, so one-to-one means that each x and y is paired up by itself. Okay, so this last one is a function and it's one-to-one. -1 goes to -1, 0 goes to 0, 1 goes to 1. Okay, now from a visual standpoint, we haven't talked about this yet, but there's 2 tests. One's called the vertical line test and one is the horizontal line test. So if we think about it, the vertical line test just means if I draw a vertical line on my graph, if it is a function, there will be no points anywhere on the graph where it crosses the function twice. Okay, so if we look here, this first one right here, this would not be a function because you see this blue dotted vertical line, it touches it once, twice. Okay, maybe someone else drew it right here, it would hit once, twice. Someone else drew here once, twice. There can be no spot on this graph where if you draw a vertical line, it touches twice. So it fails the vertical line test, it says, which means it's not a function. Okay, if it fails the vertical line test, it does not matter if it passes the horizontal line test. It will not be one-to-one because it's not a function. Now the next one, y equals x squared. So do you see how here we have our function? Anywhere I draw a line, whether here, 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 or where they put the blue line, it will only touch it once. There is no way to draw a vertical line and have it touch twice. So we know this is a function. However, do you see if I draw a horizontal line? So the horizontal line test helps us determine if it's one-to-one. The vertical line test determines is it a function. Okay. Now, as you can see, it touches twice, so it is not one-to-one. As it says, it passes the vertical line test, but it fails the horizontal line test. I'm going to move this so you guys can see, but the final one then here, y equals x cubed. We got our function. There is nowhere I can draw a vertical line that will touch it twice, so it passes the vertical line test. Likewise, this green line, there's nowhere I can draw a horizontal line that touches it twice, so it passes the horizontal line test. Since it passes both, that means it is a one-to-one function. Okay, each x and y are paired, each domain and range are paired in a unique way there. Now, the next thing we're going to talk about today is inverse of the functions. Okay, and when we find our inverse, think of that as like our domain and our range kind of flip. Okay, so if the function is a set of ordered pairs x and y, then the inverse would be the set of ordered pairs yx, meaning the x and the y switch places. So for our first example, we just have 4 points here. So if it's 3, 7, the inverse is going to be 7, 3. Inverse of 4, 12 is 12, 4. The inverse of -3, 2 is 2, -3. And finally, the inverse of 5, 8 becomes 8, 5. Okay, and there will be some patterns we'll notice about inverse that we'll talk about in a minute. So if we look at this first function, -5, -4. The inverse of that, -4, -5. So 1, 2, 3, 4, down 1, 2, 3, 4, 5. On to the next one. -4, -1 becomes -1, down 1, 2, 3, 4. Negative 2, 3 becomes 3, negative 2. 1, 4 becomes 4, 1. And finally, 6, 8 becomes 8, 6. And if I draw these lines in, hopefully you can see it is symmetric over this line y equals x. It would fold over that and match up. Okay. Likewise, we can look here, and this original function would have been 1-to-1 because there's nothing that can cut through it vertically. Okay, so vertical line test, it passes, which means it's a function. Horizontal line test, it passes, which means it's a function. If that is the case, if it passes both of those and it's 1-to-1, then that means the inverse, this red one, would also be a 1-to-1 function. Okay, as you can see, it passes both the vertical and the horizontal line test. Okay, so example 4, same thing. Maybe pause the video and try it. You're just going to have to figure out what these points are. So, for example, 6, 1, 2, 3. So 6, 3 becomes 3, 6. Okay, this next point is 3, 2. That's going to become 2, 3. Then 0, 1 becomes 1, 0. Negative 3, 0 becomes 0, negative 3. And finally, negative 6, negative 1 becomes negative 1, negative 6. And we draw our line. And we are done. And if you wanted to, we don't have to, but this one also, if we would draw in this line, you'll notice the line y equals x, it is going to be right over the top of that. Okay, it is a reflection over that line. Okay, so I misspoke earlier. I said it was symmetric over that. If we think of these two together, but it is over that line. Okay, so give me 1 second. All right. So now the final thing we want to talk about is if we are finding the inverse, sometimes we don't have a picture, okay? So in that case, we are going to take both the x, the y variables, and we're going to switch them, okay? So we're going to switch the x and the y variables, and then we are going to solve, oops, let me fix that. We're going to solve for y, okay? So what do I mean by that? Just like we said up here, the order pairs, if it's xy, then it switches to yx, okay? So down here, on example 1, instead of y equals 9 minus 2x, we're going to switch the x and the y. We'll have x equals 9 minus 2y. Now, in order to figure out what this actually looks like compared to the other function we had, we should get y by itself, so it's kind of in the same context. Okay, to do that, we'd subtract 9. Just simple algebra, right? We're left with x minus 9 equals negative 2y. So then we got to divide by negative 2. We'll divide both of those. And right over here, so y would equal negative 1/2 x and then plus 9 over 2. So maybe I recommend pause the video, try this next one. Once again, first step, we always switch the x and the y. So x equals 3y plus 7. And then go ahead, solve for y. So minus 7 minus 7. So x minus 7 will equal 3y. Then we'll divide by 3. Do it to one side. Got to do it to both of the others. So y will equal 1/3 x minus 7 over 3. Now, we got two others. These ones maybe get a little bit more complicated just because of how they look. But once again, do the same process. We switch the x and the y. So x equals the square root of y minus 4. Now to solve for y, we got to get rid of that square root. So we'll square both sides. That'll result in x squared equals y minus 4. And from here, we'd have to add the 4. So y would equal x squared plus 4. All right. And then our final one, y equals x plus 6 times over 5. So x will equal y plus 6 divided by 5. We'll multiply by 5, multiply by 5. So 5x would equal y plus 6. And all we got to do then is subtract that 6, subtract the 6. So y will equal 5x minus 6 as our final answer. So go ahead. There is no assignment for today. There will be a Delta Math for tomorrow. Now, one thing I did forget to mention, and we aren't going to talk about this a ton, but just so you're kind of aware, the domain of this is all the real numbers. So the domain of the inverse will also be all the reals. Likewise on number 2 and 4. Okay. However, the inverse and the original function share the same domain. So if we look at this original one, y equals the square root of x minus 4, hopefully you guys remember that we know that this cannot be negative because, whoops, click the wrong button. This cannot be negative because if we have a negative in the square root, we won't be able to graph it there, right? We get imaginary. So we know that the domain is that x minus 4 is greater than or equal to 0. Okay, so if we add the 4, x has to be greater than or equal to 4. Okay, so in the same way as we look at this, we know then that our domain is not for all real numbers in that situation. So don't worry too much about that. Hope you guys have a great day. And if you have any questions, please let me know. And I'll talk to you later. Bye.